All right. Good afternoon, everybody, and welcome to the Geospatial Forum. My name is John Vogler. I am pleased to introduce our speaker today, Dr. Perver Baran. Perver is an associate professor and faculty fellow in the Center for Geospatial Analytics. She's also a faculty member in the departments of Parks, Recreation, Tourism, Management, and also in the PhD in Design in the College of Design. She holds master's and PhD degrees in urban planning and a professional degree in architecture, which I did not know until today, which is great. Her research spans the geospatial sciences, urban design, and urban and tourism planning, with current focus on how natural and built environments contribute to active living, health, quality of life, and sustainability. And so without further ado, I'll turn it over to Barbara.
Great. Thank you, John, and thanks for everyone being here. Nice to see some familiar faces from College of Design as well. And thank you particularly for being here, considering that tomorrow is break for some of us, or some of you students. So as John said, I am associate professor here in the Center for Geospatial Analytics, Home Academic Department, PRTM, and affiliated with the College of Design's PhD program. So you perhaps will guess, before even I talk about my research, that my work has got to be interdisciplinary. I really enjoy weaving design, urban planning with geospatial approaches to improve our understanding of how natural environments, built environments contribute to well-being in general and health specifically. Much of my recent work has been in the area of immersive virtual environment, and perhaps many of you are familiar with this work through Payam's work actually. But today I am going to talk about a set of studies in which I have utilized space syntax approach in a wide range of topics ranging from crime pattern analysis to walkability. So I would like also to acknowledge my colleagues whose research I'm going to refer to there actually. Certainly interdisciplinary work is being possible by collaborating with various faculty. And I had incredible students. I've continued to have incredible students. And the individuals here with stars, denoted with stars actually, were former PhD students. I'm just curious, how many of you are familiar with space syntax notion? Okay, great. Nice to see some. Some of these, the beginning part might be a little bit repeat or boring for some of you, but hopefully I will pass through those quickly. Great. Now, before I move forward, I would like to take a couple of minutes to engage you in a brief mapping activity. You have been wondering why we have these papers and pencils on the tables. So this is how we are going to use those. Please, and I'm looking to Robin, please take, everyone should take one piece of paper and a pencil. There will not be tests at the end, so don't worry. Just have fun. So everyone has pencil and paper? So I know many of you are great in digital maps. How about hand-drawn maps? So this is your tasks. I would like you to draw a map of the main NC State campus. Try to cover all of the main features that you can remember, roads, streets, buildings, main campus. You can draw whatever you want, but I would like you to focus on main campus if possible. So try to cover all the main features, roads, buildings, any other things that you remember. I do not expect accurate drawing, just a rough sketch of way you remember the campus. And please include names if you remember for certain buildings, features, etc. We are going to have a couple of minutes for this activity. I wish I had an IRB approval. This could have been a nice experiment. Okay, 1 more minute.
Oh my gosh.
Okay, I think this is enough. You can put your maps on side and we'll come back to this later, but I promise no test on this. Okay. I guess everyone is... That's okay. Okay, let's continue. For those of you that are not familiar with the concept, I will spend a little bit time just to talk about what space syntax is so that we can understand a little bit how they are used in particular studies. So space syntax theory was originally developed in the fields of architecture and urban design, mainly to describe and analyze space patterns of space in buildings, at building scale as well as urban scale. In short, space syntax provides a set of techniques to basically analyze configurational or spatial configuration properties of space. Basically, those are relational properties of space, how spaces relate to each other, how they are connected to each other. Hence, it has been shown to be promising approach to study human-related phenomena that have been shown to really depend or somehow relate to spatial configuration. In developing quantitative measures of space syntax, the urban structure, and I'm going to talk about urban structures, but the same approach is used for buildings, and there are different ways to do this, but I'm going to talk about particular one approach. The urban structure is first actually transcribed into or transferred into appropriate representation, and which are called axial maps most of the time. Although there are different ways to represent actually the urban structure, one of the most commonly used approach is through axial maps. Axial maps actually are a network of axial lines that intersect with each other and consist of longest sets of lines that lines of sight basically that pass through all open spaces in the system. So you can think about axial line to be a longest line of visibility basically. Anytime there is deviation from the line, a new axial line is being introduced. And this is one way to represent the structure. There are other ways, but let's just focus on this for now. Then axial map is used to develop a number of quantitative measures to quantify the syntactical properties of space. The most simple measure at local level is connectivity. And connectivity basically is just number of all lines that are directly connected to a line. So this line has only 2 connections, its connectivity is 2. A little bit more complicated, more advanced measure of another local measure is control. And the control is basically the degree to which a line controls access to its immediate neighbors. But this is done by taking into account the number of alternative connections that each of these neighboring lines has. So how this works, imagine that there is a route line that connects to 3 cul-de-sacs. And there is another route line that connects to 3 other streets. The line that connects to cul-de-sacs has higher control value because controls access to these 3 other cul-de-sacs. The cul-de-sacs do not have alternative entry points, alternative access points. Whereas if the other 3 intersecting lines had other lines that intersect, only one portion of access for that neighboring line will go through this route line. Then more complicated or more advanced, improved, I would say advanced actually measure of spatial configuration is integration. And integration is in general how easily one can reach a specific line in the system with respect to all other systems, or all other lines within the system. So if you consider about network of lines, which line is the most easily reached with respect to all lines with the system. So for calculating this measure, the axial map is transformed to a permeability graph, and then for each line or each space, and this could be squares if that's the main space that we are interested in, then for each space a justified permeability graph is being developed to show the linkages from this particular line to all other lines in the system. So how many other axial lines we need to pass through to access that particular line in the system. So configurational accessibility is function of number of axial lines that must be passed through if one were to move from one line to all other lines in the system. This measure then could be calculated at two levels. And if you consider this urban environment here, as I said, for each, this is line number 1, let's say, so this is the justified permeability graph for that line, how this line connects to all lines in the system. Then this is path number 29, and this is its configuration, or I'm sorry, justified permeability graph. So if we calculate this measure with respect to all spaces, all streets, all lines within the system, we talk about global integration, which gives sense of configurational accessibility, how easy we can reach this particular line within the entire system. Then we can actually restrict the analysis to a local environment, and that's local integration, where we can say we would like to consider only lines up to certain depth. So we can say I would like to consider only lines that are only 3 steps away. We are not talking about metric distances. We talk about configurational distance. Then this becomes actually a local measure, how well particular space street is accessible within its local environment. In urban design literature, most researchers utilize radius of 3 lines away, but people have tested actually various radii like 2, 3, 4, 5, and it seems like 3 corresponds quite well with pedestrian movement counts, whereas in global integration has been shown to correspond very well with vehicular traffic or movement. So both measures predict quite well, at least in the empirical research, the degree to which each street in the space bay or space in the network is likely to be used by people. Here you see this old axial map for London showing global integration value, and integrated streets are shown with darker lines. So those are basically streets, lines that are most easily accessible within entire network. Now I said this approach was developed in the field of architecture, particularly within University College London. And London has been very proud of the origins of space syntax. So the axial map of London was projected actually on the floor of the opening ceremony of the 2012 Olympic Games. I know that the space syntax group at UC London actually worked with the Olympic team to develop the master plan to account for how the Olympic village is connecting neighboring communities. So basically it deals with accessibility, so they tested different ways how communities could be actually connected to Olympic village. Okay, so next I will present few studies in which I have utilized this method, and I will try to focus more on the ways how space syntax measures have been integrated with other GIS data sets. I'm not going to focus in depth on findings. I will mention here and there maybe a few of the main findings. One of the first areas in which I have used space syntax was a study examining crime patterns in town of Cary. And I approached a colleague in sociology who teaches community crime, and I was surprised that he already was familiar with space syntax notion. And our overall goal was actually, and we had a student, Umut Toker was a former PhD student in College of Design. We were basically just interested to understand how syntactic measures relate to crime patterns in Cary. Now, space syntax is very relevant to study crime patterns. Are there any sociologists here? No? Okay. Routine activity theory, which is a social theory, claims that spaces or targets that are easy to access are actually potential targets for offenders, and they attract more crime. They actually contribute to crime occurrence. It is assumed that actually targets that are easy to access, like property or people, will motivate the offenders. They are seen as opportunities actually to commit crime. So using this theory, then one would expect that areas that are globally most integrated, because they may attract more people, there are more targets, so there may be more crime in these spaces. Well, urban design literature, on the other hand, says areas that have high circulation, high number of people or circulation of people basically serve as natural surveillance, provides another layer of protection against crime. So one actually contributes and the other may deter crime. So how this is basically unveiling in Cary was the main focus of our study. For design literature, some of you may be familiar with Jane Jacobs' notion, eye on the street. Basically, if we have more people on streets, then criminal activity is being deterred because there will be always guardians that will actually protect or be ready to act upon if there are any offenders. So for this study, we focused on 4 property crimes which are most relevant, on larceny, robbery, burglary, and auto theft. And here you see a map of distribution of these crimes over a 3-year period, 2001 to 2003. And I would like to say Cary is quite a safe place. It's not like there is high criminal activity, but still there is some crime. And it's a very homogeneous suburban community, so we wanted to see how actually the syntactical measures may play a role here where crime occurs. To calculate, basically, for the analysis purposes, we aggregated, first we geocoded the crime incidents, and then we aggregated the counts by parcels. So parcels were basically our unit of analysis, and here you see distribution of numbers of crime. You see this highest area over 3-year periods had 599 crimes. Certainly we included set of variables from social sciences. Many social demographic variables are related to crime, like population density, youth concentration, level of education, etc. And we developed these measures. They were basically from census tracts, but they were then transformed to each parcel. So each parcel had these measurements. Land use is very important variable for crime because certain land uses actually are functioning as attractors, and they are called magnets for crime actually. For our study, we identified 2 sets of magnets, and we'll talk about that, but this is another layer of information that was included. Then we developed the Axial Map using the street network for Cary, and here we see global integration values. And so the lines that are shown in red are the most globally integrated lines within the system, and blue are the least integrated, and they are called segregated lines. Social scientists do not want you to use that term actually. It has some other denotions because meanings. But this is symbology that in general you will see in space syntax literature. Red indicates the most accessible lines. Then it's orange, green, and the least accessible lines are blue. Since our analysis was at the parcel level, we then transferred or linked these syntactical measures of axial lines to appropriate parcels. So in a sense, you see the accessibility of the parcels within the network if you consider only town of Cary, red again being the parcels that are most appropriate. The database for analysis included crime incidence data, number of crimes, as I said, space syntax variables, census data, parcel level land use, and we identified two magnates from land uses. Magnate one category was movie theaters, hotels, motels, gas stations, garages, and restaurants. They had similar attractions for crime. Some of these are more nighttime activities, but there are some daytime activities as well. And separately, interesting was the category of retail, stores and shopping malls, as different type of land use category that attracted crime. Few main findings we did regression analysis for this. Basically, both in bivariate and multivariate analysis, global integration was positively associated with crime, so higher accessibility at the overall level, there was higher crime. The coefficients were very small, considering the number of cases we had. And connectivity, surprisingly, was negatively associated with crime. Specific land uses actually and distance to such land uses explain most of the variance in the log counts of the number of crimes. We include, I forgot to mention, we included distance measures. So for each parcel we had how far it is from magnate 1 land use and from magnate 2 land use. However, we found interaction effects for all 4 crime types. Basically, global integration interacts with movie theater, hotel, motel, gas station, garage, restaurants to produce higher crime rates. So if we had a gas station that was on globally more integrated line, it was predicted to have higher crime than otherwise. However, connectivity interacts with retail to buffer its effect. Recall, I didn't mention this, but retail was the strongest effect on crime. But if they were around high connectivity areas, then their crime went down a little bit. Then it's interesting to understand it's kind of what they mean. When we can come back if we have questions about what this may mean. Now, the second study that I'm going to talk focuses on place legibility, and particularly this was Ishang's doctoral dissertation work. He wanted to understand the relationship between objective and subjective evaluations of urban environment. Objective measurements were coming from space syntax, and more subjective evaluations were actually coming from cognitive maps and the notion of place legibility. Now, in his seminal work, Kevin Lynch introduces the notion of place legibility as ease by which the elements of environment are being recognized and put into a coherent picture. So the elements that Kevin Lynch has identified for urban spaces are these 5 components basically, and through certain cognitive maps, he has identified that when people can recognize these elements and they can put those in a coherent picture, this place may be more legible. And it is recognized that place legibility is crucial actually in facilitating people's orientation within city or urban environment. Hence, it is one of the main desirable qualities in urban spaces. Urban designers have developed a range of methods to measure place legibility, which is a very subjective component. One way is to measure wayfinding performance. Few other indirect methods are sketch maps or scene recognition tests. All these methods are quite time-consuming. You did the sketch map in a couple of minutes, but that's usually not how it is done. And most importantly, they are actually developed post-construction, usually. Certainly for designers, it's important to have tools that they can predict place legibility up front as they design actually spaces. So this is kind of very general conceptual framework of Ishan's work. He was interested to see the linkage between place legibility as measured by cognitive representations and spatial configuration of space, which was measured objectively through space syntax techniques. In particular, he was interested to see if one notion from space syntax, intelligibility, can predict place legibility. We talked a little bit about perceived legibility. I didn't mention about intelligibility. Intelligibility is also a concept from space syntax. It's not very extensively used, but basically it's very simple correlation between global integration and connectivity. So it's basically Pearson's R. So if we have line or street that is globally very integrated, at the same time locally well connected, this will lead to intelligible system. And Peponis and Weinman says or claim that an intelligible design is one that is understandable by gleaning the structure of the global system on the basis of the structure of the local area. Basically, the level of correlation indicates this degree. So this is a good way to compare different structures in terms of intelligibility. So there, and it is claimed that at the same time that this intelligible system is easier to navigate than unintelligible system or system that has lower intelligibility. From this regard, there might be some connections there. So he wanted to see if actually we can use the notion of intelligibility to predict perceived legibility. For his study, he selected two neighborhoods in Changsha, China. These are he lived there, and initially he developed syntactical map for the entire city, and here you see only fragment. Then looking to neighborhoods within the cities, he identified two neighborhoods that are across river from each other, Rongguanzhen and Dongpailu. They have same number of axial lines, very similar very similar characteristics in terms of mixed-use development, residential development. However, one of these neighborhoods had quite low intelligibility. R was 0.19, and the one on the right has higher intelligibility measured as 0.41. So he did actually two small studies in both neighborhoods. The first study was a cognitive mapping activity with 65 residents in both neighborhoods. These residents were approached in open spaces, and they were asked to develop a sketch of their neighborhood, how they remember their neighborhood. This is something similar to what you did today. And following that, they also had a kind of brief semi-structured interview with residents just to talk about what spaces or what features actually were why they included certain features in the maps than others. The second study was an experiment, actually, real field experiment, where he had 48 college students that were not familiar with these neighborhoods. They were matched and randomly assigned to one of these neighborhoods. They went and explored this neighborhood for an hour. Then they actually convened and did a cognitive mapping exercise, including sketch mapping activity. They had also scene recognition test and post-experiment questionnaire, basically to measure their perceived spatial cognition. So here you see a couple of examples of the sketch maps from residents, and here are some of the students developing the sketch maps. So both groups actually did the same activity. One of these groups are familiar with these environments and the other not so, but they had 1 hour to explore the space. Then only for students, the group that was in the experimental group completed also scene recognition test. For this, they were given scenes from 16, they were given 16 pictures taken from the neighborhoods in which they explored. 12 of these were actually from the neighborhoods, and 4 were outside of the neighborhood. And they had to locate these scenes on an actual publicly available roadmap of their neighborhood. So the notion was to see how accurate they will be able to place these scenes. And the scenes taken varied from globally very integrated streets, medium integrated streets, and very low integrated streets. With this, they also completed a post-experiment survey measuring their perceived spatial cognition. Then all these sketch maps were analyzed, and quantitative measurements for landmarks and paths identified in the sketch maps were developed. So basically, for each landmark that appeared in everyone's, not in everyone's, but he actually counted all landmarks or buildings that appeared in everyone's map, and then assigned points based on not only frequency, how many times this particular building was included, but also on the accuracy. So there was some rating system if the landmark was placed in the right place, in the same block, or away 2 blocks away. They were all scored. Similarly, he scored actually the roads, the paths that appeared on the sketch map. So this is visual display of the scores for landmarks and paths. And in terms of analysis, when he looked to how syntactical measures correspond to these scores, for landmarks, only global integration correlated well, or it was basically predicting landmark scores, both for residents and students. That was interesting. And this was even more for students. For students, it explained about 32% invariance of landmark scores. Similar analysis was done for path scores against syntactical measures. Now for path scores, local integration or local syntactical measures were more important, both for residents and students. And for students, again, this was stronger predictor than for residents, but both groups had significant results in terms of having local integration and connectivity to predict their path scores. And one of the most important actually part of this research was really the comparison of the notion of cognitive representations across intelligible and less intelligible neighborhoods from the experimental study. So these are the kind of highlights of the experimental work, which compared the scores for cognitive representation from sketch maps, focusing on landmark scores and path scores, scene recognition scores, and 3 questions from the survey that focused on spatial cognitive ability. Basically, they were asked how easy it was to draw the sketch map, their confidence in drawing the sketch map, and confidence in scene recognition. And all except landmark scores were actually statistically significant across neighborhoods. All these scores were higher in high intelligibility neighborhood vis-a-vis low intelligibility neighborhood. Okay, so this is something perhaps you will recognize. These are the global integration and local integration maps of our campus. So you can look to your maps now and see if you find any resemblance between your maps and some of the lines here. Again, remember the red lines are globally integrated lines, and here for local integration, these lines are locally integrated lines. The gray points represent crime on campus. At one point I was interested, we did a small study that we looked to crime patterns and some of these notions on the campus. So yes, I wish that I had really IRB. We should have used your sketch maps for a small study here as a group, CGA experiment. Okay, the next study focuses on actually notion of space syntax and walking. And this compared walking in an urbanist neighborhood and a set of suburban neighborhoods. The physical activity literature has indicated number of built environment variables that correlate well with physical activity. Few of these are population density, mixed-use development, and street design. Street design usually is measured with street connectivity in most of the studies. And here is the definition how street connectivity is being defined: the directness and availability of alternative routes from one point to another within a street network. Most physical activity researchers have utilized actually average block size or street intersection density to measure connectivity, street connectivity. These are discrete features, and they do not take into account really relational properties, how the network is connected to each other, in spite of definition pointing to this higher level connectivity between different points. So in this particular research, we wanted to see if the integration measures, control value, and connectivity correspond to walking in these two neighborhoods. My colleagues for this research, Daniel Rodriguez and Asad Katak, who formerly were faculty members at UNC Chapel Hill, already had a study, and they had collected walking behavior information from residents of Southern Village as example of a new urbanist development, which is being developed actually as a neighborhood that improves walkability, or walkable neighborhood basically, and set of conventional neighborhoods that are located northwest of Chapel Hill. Their data came from surveys and activity logs. But they have actually compared minutes walking and number of trips for utilitarian and leisure walking between these two types of neighborhoods. Assuming that, since new urbanist neighborhood is more walkable, will lead to more minutes being walked or more trips being taken, both for leisure and utilitarian walking. However, for this study, we wanted to see, independent of the type of the neighborhood, if syntactical measures actually play a role in how much residents walk. So this was their original data, mail-in, mail-back surveys, travel diaries. Then we developed GIS point layer from respondent addresses, and these are just approximate locations. Then, using the vehicular and pedestrian network, we developed two axial maps, one for cars and one for people. Particularly in Southern Village, actually, there are so many opportunities for people to move on foot without taking cars, so we had to look to both networks. And then we calculated local integration, control value, and global integration. So for this study, the dependent variable were number of trips per day and number of trips per day for leisure and for utilitarian walking. We had some other explanatory variables, and here you see maps for global integration for both neighborhood types. In general, in space syntax research, the 10% highest global integration core is delineated separately, because really, if you would like to think about the center of central activity, that's a good core to consider. And local integration and control values for Southern Village. So the results show that global integration and control values positively predicted the walking behavior in for both neighborhoods, because the analysis was done actually jointly. Surprisingly, local integration was negatively associated with leisure time walking. So there is a little bit difference between what type of spaces people select for leisure walking and what type of spaces we select for utilitarian walking. And for those not familiar, utilitarian walking, if I would like to go to a store, I would like to visit my friends, so you have a purpose, you have a destination in mind, and then you kind of walk. Leisure walking is just strolling around just for leisure purposes. The previous study looked to walking behavior in residential environment, and this study, next study, looked actually to walking behavior in a park environment. For her dissertation work, Yuja worked in two neighborhood parks in Beijing, China, and she was focusing actually particularly on elderly walking. walking is very important for elderly for various reasons, but one is because it's a moderate level physical activity, it actually contributes or can help elderly people maintain active lifestyle. So that was something that is particularly relevant for elder population. She selected two parks, Redingu Park and Yuetan Park. These are mid-sized neighborhood parks in Beijing. They are in the same residential district. Some scenes from these parks, you can see they are very well maintained, so that was some homogeneity there. She conceptualized the parks through pathways. Pathways are actually most important element in structure in the entire park, because through walking they actually allow a park experience. And in order to consider variables that could be integrated, she did extensive literature search, and she categorized into two main categories. One set of variables that related mainly to pathway attributes, pathway itself, and the second to the pathway surrounding. The first one included physical attributes like type of pavement, form of the pathway, availability of benches, light fixtures, etc. Then configurational attributes included the standard global integration control value, but she also included depth to gates and depth to landmarks. This depth is not metric depth, is number of trails or number of paths one needs to reach particular trail from the gate. So on average, how many paths someone needs to take to reach that particular path, a particular path of interest. This is important because parks are more controlled environments. There are only 2-3 entry points, and those are points where most people will come in. So inevitably, they will be spaces where people will be mainly observed the most. And then she included also two different spatial dimensions and visual dimensions. She measured number of observed elderly. She used gate method. Basically, she had two digital counters, went and stood midway point along the trail, and she included all trails in both parks. And she stood in the midway point and then just counted number of elderly that passed that imaginary line. And on one hand, she was recording other adults because she wanted to see if actually there is any correspondence between where elderly people walk and do not walk. So this map actually shows number of people observed overall across 3-week period. Each pathway was observed 27 times for 2 minutes. So this is kind of aggregate number of people observed across 3-week period, across 27 observations. And she was able to conduct 46 interviews with volunteer elderly to talk about features that they like and to see if actually her statistical analysis, to provide some shade to her statistical analysis. Then for configurational analysis, she used a little bit different representations. She didn't follow the axial map representation, but she used the convex map representation in which all spaces were identified, and these are paths, but also other activity spaces, like gathering spaces or playgrounds were identified. And then there was another important deviation from previous approach, how the pathways were actually delineated. While in standard axial map, this path perhaps is going to be shown with 3 or 4 axial lines. She used stroke-based approach, which actually considers the movement pattern and suggests to use just one line, one stroke to represent a pathway. And it seems like this was a little bit more relevant for park environment. So she didn't divide the trails to axial lines, but used this notion of convex space with stroke-based representation. And then using the tools available, she calculated this is the connectivity map basically of all spaces and within the park, including activity areas and pathways. Using this graph basically, she calculated syntactical measures and for all, including all spaces, but here we see only syntactical measures for paths because that was the point, the main focus. Again, red indicates the trails that were syntactically most accessible. This is a global integration map. This is control value, and this is the pathway average depth from gates. And this is pathway average depth from landmarks. So she did couple of sets of analysis. One that particularly focused on configurational attributes. Two of these, global integration and control value, positively predicted number of elderly observed on pathways. It was interesting to see that pathway connection with activity zone, this is another variable that I didn't indicate initially. If the pathway connects to certain other activity areas, such as gathering places or fountain area or playground, they were indicated with yes, having one activity zone on one side or having 2 or 3 or 4. So this was actually negatively related to number of elderly observed. So perhaps elderly avoid spaces where there are other type of activities, at least for walking. And the last project, I do have a few minutes. I think I will have a little bit time for discussion as well. The last project builds on previous project, and again was led by Yujia Zhai, but this time as a faculty member at Tongji University in Shanghai. She focused on looking to walking behavior in 2 big forest parks. Shanghai is the second largest city in China with 24 million people. And the municipality maintains few regional parks in addition to local neighborhood parks. So she actually studied 2 of these parks. And there, in addition that in this study she focused to larger parks, there were 2 other distinctions from the previous study. It looked actually to adult walking, and she used GPS units to collect park use data. In the previous one, she used gate method, just manually counting. This one used GPS units. Here you see the master plans and the circulation areas for the 2 parks. Some scenes from these parks. And in addition to trail configuration attributes, since we are talking about really very large parks, she included in her analysis some distance measurements, like distance from gates, trail length, trail width, and openness, and few other variables. Most interesting part was actually collection of park user data through GPS units, and park users, as they entered park, were invited to participate in this study, and volunteers were given these GPS units. They were turned on, and they returned them on their exit. There were some people that were in the park for 5-6 hours actually, and they returned them on their exit from the park. And they were able to return the units at any of the exits. They were instructed that the managers knew this, so they collected the GPS units. So overall, in one of the parks that were in Taiwan Park, there were 134 users that actually had valid GPS tracking data with 10-second interval. And in Gongqing Park, there was 170 users GPS tracking data. These data were collected in September 2016 over 2 weeks, for 2 weekdays and 2 weekends for 2 weeks. And here you see the GPS data for 5 visitors in one of the parks, and this is the GPS data for 3 visitors in another park. And here are trail use level. These are aggregate numbers obtained from GPS data that shows the number of people being observed on particular trail. The red implies higher numbers, and green is the lowest numbers. Then she used the same approach to develop accessibility graphs. Again, she used all spaces to develop these graphs, but in these maps, only global integration of the maps are being shown. In this study, actually, the data we are still analyzing. We are looking to different kind of connections, basically, how this may play a role in this large park. Then, so this is kind of still studying going on. In these two, okay, I don't know how to sign. In these two projects, we look to accessibility within the park. So how the pathways are connected within the park. There is a new line of research or recent research that looks actually how the parks are connected in, syntactically within the entire city network. So we do have rich data set for Durham parks, 20 Durham parks, and I already have developed Axial Map for Durham. So if someone, I'm talking to students, if you are interested to look to how parks are accessible within the entire network and see if there is any connection to a number of people within parks, come talk to us. Robin is here. We did a study a few years ago together, and there were a few other colleagues in the team. So as I finish my presentation, I would like to thank you, and I would like to ask you, are there any other areas where you think space syntax or configurational analysis could be helpful? And any questions I will take if you have. Thank you. Yes.
So I'm interested in how extent of your study area impacts the results of your study. It seems like in some, you can say a park has a very clearly defined boundary, whereas some of your other studies had fairly arbitrary boundaries within an urban environment. How does that play?
Great question, and this has been actually debated in space syntax literature. There is this edge effect. So really the boundary, to a certain degree, influences the values, particularly global integration. When we talk about local integration or connectivity or control value, those are less important. What has been suggested, usually we get some buffer to account for this, and I think Hilliard suggests to get mean depth for the most integrated axial line in the system. If we go mean depth beyond, so we need to develop actually axial map for larger areas so to avoid that edge effect, but it's a very important question. In parks, really, they are very restricted and it's very defined, and this is used for building scale analysis, which are also very well defined with entry points, but for urban spaces it has been a critique, I think, in a sense, but that's how it has been taken into account. Any other questions?
So the study you did in Cary, it seems like Cary has some qualities that are maybe different from other places. Like Cary has a lot of suburbia. There's very, very little concentrated housing, I think. And so how does the results from that compare to studies that have been done of a similar kind in other types, like New York City, or, I mean, I'm sure these looked at.
Yes, I understand what you're asking. Yes, Cary has many of these lollipops that we say, cul-de-sacs, that lead to very high segregated areas. So there are two different ways to think about this. But I think crime pattern analysis is quite extensive in space syntax literature, particularly in Europe. Cities use actually space syntax to manage their crime patterns within the city. It seems like for Europe, highly integrated streets have less crime. In US, there is a study done in Ypsilanti, I think, Michigan. There was some work done in Atlanta, I think. I'm not sure about in Europe, but certainly each city has different dynamics, so it needs to be looked within the city itself. And some spaces are more crime prone. Consider Baltimore, let's say if you compare Baltimore vis-a-vis Cary, definitely they will have different patterns. So it needs to be looked within its own context, I think.
So as a slight segue to my question, so great body of work, thank you.
Oh, thanks.
For reviewing all of that. So can you think of cases where these kinds of data have been effective in influencing policy? Building form or crime is kind of an obvious one.
Right. I think the most that I'm familiar with because of Space Syntax Network, there is if you go to spacesyntax.org or .net, there is a group at UC London that actually does this for educational purposes. And by the way, there is a software available for free, Depth Map, that allows to do this analysis. There is, but unfortunately it works with, I will come back to your question, works with AutoCAD data. There is another software developed in London by Bin Jiang, which works with ArcGIS, but are version dependent, so he's not able to catch up with ArcGIS versions. Last one I think was 10.3, but they are free for education purposes. But the group in London actually does this for basically solving practical problems. And I know there were some plans where they utilize space syntax, let's say, to look to accessibility of the Trafalgar, the area around Trafalgar Square in London, to talk about actually how this space is being integrated within the surrounding spaces. Sometimes, including just one street, may change the dynamics, how spaces are connected to each other. So this allows a quick way to actually analyze individual syntactical measures. And there is some research that shows that they correspond with retail sales as well. So where you put your stores actually, perhaps if you would like to have coffee shop, you do not want to put in very segregated or low integrated areas where there is no through traffic. Basically, there are land uses that are dependent on through traffic, and for these land uses, I think this is important to consider. If you allow people to move around randomly in this system, they will bump to each other most often in these highly integrated areas. So I don't know if this answer, but one is for urban design for accessibility. It has been used quite often. I know few campuses have used this actually to design their spaces within the campus.
I mean, you can think of walkability, right?
Oh yes, I'm not sure if it is used for practical purposes in US, although there was attempt at Georgia Tech. By the way, there is a group at Georgia Tech, John Peponis, that developed one software for space syntax analysis, and Gene Weinman, who moved to University of Michigan, they have their own small kind of software. So I think there was some effort for utilizing in Atlanta, but most of this work in practical terms is in Europe actually. Yes, Teresa.
Very interesting. So one of the things we're looking at is kind of the concept of awareness, self-reported awareness, relative to components within overall park systems. And are you familiar with any research that might be looking at that correlation, or do you see an application for space syntax in that?
When you say safe self-awareness in terms of being able or sharing the same space, awareness of others, or
Awareness of availability.
oh, awareness of availability. No, I do not know if people have looked to the notion of awareness, but there are a few studies that have looked actually to how parks are integrated syntactically within the city to show the accessibility of parks. Because if we distribute our neighborhood parks in a way that are less accessible from residential areas, people need to put extra effort to reach these parks. But if they are distributed in a way that are easier to access, even if I do not plan to go to park, if I just walk through to reach another destination, if that's on my way, maybe I will spend 15 minutes there and continue. So this through movement is something that might be interesting to catch up. And I think that's something I mentioned. I would like to see if our data in Durham correspond to some of this actually.
In the walkability study, is there any accounting for self-selection between those two neighborhoods?
Great question, but it was not part of our study because that could have come in the initial study that Daniel and Asa did, where they compared walking in new urbanist neighborhood, yes, it's very well cited, and suburban neighborhoods. There people say that people that select to live